Hey everybody, welcome back to Technically Bitcoin. How's it going, Tyler?
It's going good. I'm excited flying to Nashville tomorrow. Getting excited for the crazy, fun, festive week full of orange coming
Man,
up.
I'm excited. I'm excited for your party, man. I'm excited for the Wizard party.
Dropping some alpha.
Let's go. Always need to drop some alpha, man. That's what we gotta do. Everybody, you already know what Technical Bitcoin is all about. Today, we have some really cool stuff on the agenda. So, Tyler, today we're gonna be talking about covenants, which is really cool topic because I guess people, if you have not been living under the rock, and if you have been listening to the countless of Twitter spaces and podcasts about OpCAD, you have definitely heard about covenants. And, me and Tyler, we both believe that this is a very important topic to cover. And there could actually be maybe even some kind of misconceptions, around covenants and Bitcoin in general. And so that's something that we want to try to uncover today and talk about what covenants actually are, what they mean, and how OpCat is going to make them better. So let's get into it, Tyler.
Yeah, I'm excited to chat about this today. So, really quickly, just an overview of where we're going today. We'll talk about what covenants are and how you can put restrictions on who can spend Bitcoin today. There are actually two ways that covenants exist in current Bitcoin. One is called time locks, and the other tends to be called Hashlocks. Then we'll talk about what OpCat enables. We'll just go through a brief example, but it's pretty exciting. And then we'll just do a quick summary of what covenants are and kind of where they're going to lead us to. So I'm excited. At some point in the future, we'll do a CatVM episode where we take this and put it all together and say, okay, now that we've learned all of these things, we're ready to tackle the beast that is CatVM. But I think it's important today just to start with the basics of covenants.
Let's do it. So, Tyler, do we have smart contracts on Bitcoin or not? Everybody says we don't have smart contracts on Bitcoin. So, what's the deal here?
Yeah, so I love this question because so many people like to say, oh, Bitcoin doesn't have smart contracts. Bitcoin does have smart contracts. It has very dumb smart contracts, but there are smart contracts. We love them. It's not our fault that they're dumb. Ethereum, good for them. They graduated college. They were the valedictorian. They had their 4.0 GPA. Over here at Bitcoin, our smart contracts are kind of working their way through kindergarten math. So we can do addition. We can do some simple signature checks, some simple hash checks. But outside of that, unfortunately, we're pretty limited. But I think that's really a good place to start. So before we even talk about covenants, I'd love to spend a minute or two just talking about how the flow of Bitcoin is restricted today. So I guess, Jan, question for you, right? You have Bitcoin in your Xverse wallet. What
Yeah.
prevents me, Tyler, from just going and taking it for myself today? Like, why can't I just go spend it to my own address?
I mean, you cannot go spend it. I mean, you don't have my private key, right?
Yeah.
That's the thing. So that's the number one and most important reason, I guess.
Yep. So, really, if we took a look at your, here's Jan's Xverse account. Let me pop it in here. Xverse. And let's say you had 10 Bitcoin in here. Well,
I wish.
Yeah,
I wish.
Yeah, don't we all? And when we say Jan, what does this really mean? Well, in Bitcoin script parlance, what this means is that in order to spend this, this is at some address. So, it probably looks like BC1P XYZ. And in order to spend this, what you have to do is prove to me that you own your private key so that the private key that's associated with this address, this bc1p.xyz, right?
Yeah.
And this is actually how 99% of the Bitcoin out there is stored. It is stored behind some private key signature check. It says, prove to me you own your private key. If you can prove to me you own your private key, then you're allowed to spin this. So the only way I could steal your Bitcoin is by stealing your private key. So that's one way that Bitcoin, and the primary way we restrict the flow of Bitcoin today. That is not the only way we can do this on the Bitcoin network. So as a very simple example, I could take another 10 Bitcoin, and let's say I owned them. I could spend them to a new address, and let's say this one is bc1p.abc. This address could say, I don't need any signatures. I don't need any signatures at all. The thing that this address could say is, provide me two numbers that add to 4.
Interesting.
And so yeah, go ahead.
No, go ahead. I'm just like, my question was like, this is something we can do today, or we're not able to?
This is something we can do today. Because
interesting. Okay.
In script, we have this opcode. It's called op-add. And what this does is it adds two numbers together. And so we could write a script that basically takes as an input, it would take in two numbers. So, number 1 and number 2. And then the script that would check it, it would basically add these together. And then there's another opcode called verify. And we would actually have there'd be a 4 in here. So literally the number 4. So like op-add would take these two numbers, it would add them together, and then verify would check that 4 is equal to the sum of these two numbers. So this is like a very stupid explanation actually of how script works today.
That's interesting. Could you actually give an example of why you would want to use this in practice? Like what would be the application in the real life for like sending Bitcoin only if like you have this kind of script that is like very basic, simple, whatever, but what would be the real life application of this?
Yeah. So if we actually went and blew out this prove that you own the private key thing I told you earlier, this actually looks quite similar to what I wrote down here with the inputs, except instead of op-add, we use an opcode called op-checksig. And what that does is it takes a signature and it checks that it's valid for the transaction you're signing, and more specifically for the UTXO. So it's basically saying, give me proof that you own the private key, and then this checksig function does that. So instead of op-add verify, prove that you own your private key, literally does op-checksig and then op-verify. And so that is like how your Bitcoin is restricted today. So I know like we haven't done an episode on opcat, but we've talked about how opcat, lets you take two things on the stack and put them together. Here's like a couple other examples of what things that are happening on the stack that are restricting Bitcoin within script. So when we say Bitcoin doesn't have smart contracts, this is why I'm saying, no, Bitcoin has smart contracts. I'm telling you that they're very dumb, right? You can do checksig, you can do op-add, you can do addition. There is no multiply opcode. We literally can't multiply things, which turns out to be very frustrating when you want to do math. And so there is smart contract functionality on Bitcoin. Your Bitcoin is secured by smart contract functionality. Don't let anyone tell you otherwise. We just have a very restrictive language in terms of the types of smart contracts we can write. And I think that is a good segue into covenants.
Yeah. No, that's great. Totally. And so, let's go into covenants. And so when we look at the definition of covenants, it's basically the restrictions on an authorized spender's future spend of Bitcoin. So what you're basically saying here, obviously this is kind of like an obvious and not obvious, but this is like the professional definition of covenants. But basically, all of these things, these examples that you put in, that's covenants, right? Like you're basically using the Bitcoin script in a certain way, and we call it covenants whenever it's actually touching the fact how Bitcoin is going to be spent.
Yes. So I think the the slight change here that I looked up right before we talked about this is, I think the way Bitcoiners like to define it is this authorized spender's future spend of Bitcoin. And so basically, how do we rule out all of these check sig type things and say, okay, like what other types of restrictions can we put here? Right. So, but I think by and large, if you just want to generalize it, in my opinion, I think it's totally fair to say all of Bitcoin's smart contracting is covenants. It is all putting restrictions on who is allowed to spend the Bitcoin where. And the real question is,
I just want to say, Tyler, I think maybe, my kind of understanding was a little bit, or my explanation of my understanding was a little bit confusing, because like based on what you're saying, to me, covenants are extremely important for anything that you do with Bitcoin. I mean, Bitcoin is all about moving Bitcoin from one address to another, right? No matter what you do. And so like covenants are basically being touched all the time in, I would say, in every transaction based on what we just discussed, right? Is that correct?
I think that is correct. I think if you talk to a Bitcoin developer, though, they have a very specific idea of what a covenant is, right? So they would say, a check sig is not a covenant. That's just script. That's how our smart contracting language works. They would say, to me, a covenant is, how can we prevent someone who like already owns the Bitcoin, right? So Jan, you own the Bitcoin already. Can I add additional restrictions on when or where that Bitcoin can go?
Yeah.
So that part one is like showing that you have the authorization to spend the Bitcoin, right? That's either the signature or providing two numbers that add up to 4. When we talk about covenants, what we're talking about is, okay, after you've provided me the numbers 1 and 3, is the script able to further restrict where that Bitcoin can go afterwards, or when it can go afterwards? And so those are the types of things when we talk about covenants that by and large we're talking about. But I think it's really important to understand this basic, this basic difference, right? Script is one, allowing us to show, are you able to spend this now? And then the second question is, where or at what point in time are you able to spend this? So are there additional restrictions?
Makes sense. Yeah, that's clear. That's clear. Cool. So what do we have next here?
Yeah. So before we talk about Hashlocks, I just want to quickly talk about what a hash function is. And we're not going to get super deep into this, but it's used all the time in cryptography. The important thing to know is that hash functions are what we call one-way functions. So given an input, they produce an output. If I give you, Jan, that output, you have no information about what my input was, right? So it's kind of like putting a bunch of different fruit and vegetables into a blender and holding the button down for 30 seconds, if I then give you the output of that, you're like, I don't know. Like, this went through a blender. I don't know what is in this thing. That's essentially that is what hash functions are. Hash functions are blenders for cryptography. So they produce an output, again, that you can't figure out anything about what the input was. So what Hashlocks do, they were kind of they've been in Bitcoin since the beginning because we've always had hash functions, but they've really come about to be more interesting around this thing called DLCs, or discrete log contracts. And so those are actually used in Lightning, and they're used in Liquidium for our resident degen. So what I wanted to talk about, I think, here is maybe just walk through an example of how Hashlocks are used in Liquidium and how they're kind of a form of covenant that restricts the spend of Bitcoin.
Amazing. Let's do it.
So when you go and you take a loan on Liquidium, we're going to talk a little bit about what happens in the background. So I think most of you know that there's this Liquidium oracle that decides whether the loan was successfully paid back or the loan was unsuccessfully paid back. And what that oracle is actually doing is it's generating a couple of hashes, one for each type of outcome. So maybe we can just draw that out. So there is outcome number one, which I'll call paid back. And then there's outcome number two, which is default, right? So either you pay back the loan or you defaulted on the loan.
Yeah.
So the Liquidium oracle is going to generate some secret phrase that corresponds to both paid back and default, and they're not going to tell anyone what those are. So it won't literally be the words paid back and default. They have to do a different one every time, but for the sake of simplicity here, let's assume that that is the case. So these are the outcomes. And then what Liquidium is going to do is it's going to take the hash of the outcomes. And so this is going to look like some gobbledygook of 20 bytes. So, it'll look something like 8B6C ... DE. And this one over here might hash to 7J34 ... 8E. The point here is that these hashes, again, they don't give us any information about whether the outcome was paid back or defaulted on. So now, when you show up to Liquidium, what actually happens is you end up pre-signing for two different transactions. So, Jan, if we go back to the case where you have your 10 Bitcoin, and let's say I have a Quantum Cat. So Jan, here's your 10 BTC, and Tyler, I come in and I have a Quantum Cat. And we're gonna set up a loan. And how that's gonna work is we're both gonna put these two assets into Liquidium, and then Liquidium is gonna say there's actually two spend paths out of here. And they correspond to either you paid back the loan or you defaulted on the loan, right? So in the first case, in the happy path where, let's say I took a loan on my Quantum Cat and I paid it back, this is going to have, it's going to be encumbered to a script, and the script is going to ask for a few things. It's going to ask for one, it's going to say, Tyler, prove that you own your private key. And then it's going to ask for a second thing, which is going to be provide me the pre-image to the hash of the paid back outcome. So what it's basically asking for is it's going to say, you need to show me that the oracle has given you this secret phrase that corresponds to paid back. because what I'm going to do as the script is I'm going to compare the hash of whatever you provide me. In this case, it's paid back. But the script, I only know about this 8B6C ... DE number. And what I'm going to do is I'm going to check that these two things are equal, that the hash of paid back is equal to this. And remember, this paid back is secret information that Liquidium has. No one has it. And so if Liquidium somehow leaked that paid back information to me early, before I had paid back the loan, I could actually just take my quantum cat back, right? And so I could spend out of this as if I had paid back the loan, even though I hadn't.
Totally.
So that's the paid back path, and I guess I misspoke slightly there. There's some additional security there that will make sure that even in that case, when I go spend this, Jan, you're still getting your money back. It's not like I can just take my quantum cat and the 10 Bitcoin out of there.
Yeah.
But it would be possible for me to say, well, we're going to spend out of the paid back path, even though I haven't. And so you can see that the same thing will happen on the default path. Here, we're going to say, okay, Jan, you lent me the BTC. So here we're going to ask for Jan, your private key. And then we're going to ask you to provide whatever this default secret phrase is. And again, what we're going to do in the actual Bitcoin script is it's going to take the hash of this default phrase and it's going to compare it to 7J34 ... 8E. And if those two things match, then fantastic. Like you have successfully unlocked the hash. And if they don't, then sorry. It's great that you have your private key, but you can't spend out of this address. And so that is how Hashlocks work. They're basically a way to restrict the flow of Bitcoin based off some secret information that a third party or someone has. And when they give you that information, now you are able to spend the Bitcoin. So it is another form of a covenant, and it's used in things like Liquidium and Lightning.
I think that's pretty cool. I think it makes sense. So it's really something that, for the Liquidium case, basically these things are created at the point of me creating a loan, right? As a user on Liquidium, on the platform. So I create a loan. All of these things basically happen through the script or using the script that Liquidium wrote, whatever. And then only in those different cases, basically these specific hash locks are triggered, right? And, then I can either unlock or I just default. If somebody defaults, I can unlock that ordinal, let's say, or I get the Bitcoin back with some premium, whatever, right? And so, it's an interesting example, actually. I think it's still like maybe slightly more complicated to me, like that compared to the time locks example. But I think what we should take away from here really is that, what is the hash, right? Like that it's really kind of, it's a cryptographic way of, using information or transferring information, right? In Bitcoin, in a sense.
Yeah, exactly. I think cryptographic blender is the right takeaway from this. If you
I think
have
that's
some
great.
Secret and you want to protect that secret, you can hash that secret, and no one can figure out anything about this secret.
Yeah, I think that blender is such a great example, that you basically mix a smoothie from fruits and vegetable, but if I look at just the color, I have, I know it's a smoothie. I probably know it was made from vegetables and fruits, but I have no idea, what is the recipe, right? I cannot figure it out, so it's actually a pretty great example here. So nice. I think that's it. I don't think that I have any further questions. I think, again, it's maybe kind of a little bit more advanced session here. I think, if you guys are interested learning more about Hashlocks, maybe we should cover it a little bit more on more practical and real life examples. Maybe we can, in the future look at some of the Liquidium related transactions from the mempool. We can definitely do that. But just for the sake of illustration that these things exist and what they do, I think that's great. And I think the next step is the OPCAT covenants, because this is something that people are really excited for, right? Because OPCAT is going to introduce more expressive covenants to Bitcoin. We already discussed that. And so let's cover some of those examples and like what we are going to be able to do with OPCAT.
All right, yeah. So covenants with OPCAT. So I think up to this point, we've talked about how Bitcoin does have covenants already. It has these things called Hashlocks. It has these things called time locks. What Bitcoin, I think if we take it back up a level, there's something I want to talk about, which is how you can restrict Bitcoin flow. So you can restrict who is allowed to spend Bitcoin. And we do that through our simple things like signature checks, right? Let's check to see, Jan, that you own the private keys. We can do it through things like Hashlocks, right? Hashlocks prevent who can spend it. The person has to know the hash. They can't spend it until they know the hash. We can talk about when people can spend it, right? So that's time locks. So it's very easy. This is baked into every single Bitcoin transaction. There is a time lock field. And you can say, I'm sending you Bitcoin, but you can't spend it until block X or until X number of blocks have passed. What we have no ability to do today is restrict where the Bitcoin can go. So if I send you Bitcoin, Jan, again, I can make it such that you're the only person that can spend it. I can even make it such that you can't spend it until I give you some hash pre-image. I can make it such that it can't leave your wallet until a certain block time. I can do nothing about where you're allowed to spend that Bitcoin and what you're allowed to do with it once it leaves your wallet. And this is the key thing when people talk about wanting covenants in Bitcoin. This is the thing they're talking about. They want to be able to restrict where the Bitcoin can go after it leaves your wallet. And this is the thing that our friend OPCAT lets us do and is the really big unlock that OPCAT brings in terms of covenants.
Got it. So I guess we should look at an example of a vault, because that's a very common example, right? When it comes to OPCAT and covenants.
Yeah. So OPCAT, it allows for this thing called transaction introspection. And it lets us check all of the stuff that's coming in a transaction. And I think we can understand that well through a vault. So let's start with a good old-fashioned vault. So here is your vault, and Jan, let's say you decide to put your 10 Bitcoin inside the vault. So this Bitcoin now, it lives inside a vault, and the big thing is we have restrictions on where this Bitcoin is allowed to go. So today, the Bitcoin that sits in your wallet on Xverse, if you go click a wallet drainer link, it will leave your wallet and it will go to whoever decided to drain you.
Yeah.
That sucks. That is really an unpleasant experience. What a vault does is it says, we're going to put restrictions on where the Bitcoin in my vault is allowed to go. So in a vault, you put a restriction and you say, this Bitcoin can only go to this place that I'm going to call the waiting room. And I can perform a transaction. And what I do is I say, okay, I want to take my Bitcoin out of the vault and I want to take it over here into the waiting room. And when I do that, I specify where I want the Bitcoin to go next after the waiting room. So let's say you wanted to send it to me, Jan. You would indicate here, Jan, I want to send it to Tyler. And you put my address in when you do this transaction that takes the Bitcoin out of the vault and into the waiting room. And now this Bitcoin lives in a new state that has a new restriction on where it can go. So now this Bitcoin can go two places. It can go to Tyler. So it can go to my address over here. And ultimately I could end up with 10 BTC. So that's one possible path. Or it can go either back into the vault or to some other cold wallet that you specified when you set up the vault.
Interesting. Just a question here, Tyler. What are the restrictions when it comes to you specifying where the Bitcoin is going to go? Is it like 2 addresses potentially, like you just mentioned, either to you or a cold storage, or is it unlimited amount of addresses? Is there any restriction when it comes to setting up the vault this way, for, let's say, self-custody, better self-custody?
Yeah. So in general, you'd probably end up with what I would say is like 4 places it can go.
Okay.
Or I guess 3 where it can go out of the vault. So first, it always goes to the waiting room.
Yes.
Right? That is one place it can definitely go. The second is it can go to the place that you specify when you spend it into the waiting room. So that's like a bit more abstract, but this is, again, what's really cool about OpCat covenants is unlike something like CTV or other things we have today, we can actually specify at spend time when it leaves the vault where that one more hop away place is allowed to be.
Okay.
And that's something we can't do right now in Bitcoin. So it can go to the waiting room, it can go to the place you indicate you want it to go in the future, or 3, it can go from the waiting room to, let's say, instead of going back to the vault, here I'll try and delete this little thing. It can go to some cold storage place. So let's say this is another cold storage that Jan, you own.
Got it. And so basically, for my understanding is, so how this works on the product and on the user interface level is that I am basically going to set all of these things in advance, right? So I will set up this vault that is related to my private key. And basically every time something is spent from that vault or something is spent from that specific address, it first goes to the waiting room automatically, and then I can choose from those predefined destinations whenever it's triggered, whenever some sort of transfer is triggered, correct? But I cannot really change it after some sort of transaction was already triggered from the vault.
Yeah. So I'd say when you set up the vault, you're going to specify 2 things. You're going to specify 1, the private key that owns the vault, that is allowed to spend out of the vault. And you're going to find 2, what this second place it can go to from the waiting room is. Does it go back to the vault, or does it go to another wallet that you own? So let's just say you want it to go to another wallet because most likely, if let's think through the adversarial scenario. If I stole your private keys and I spent the Bitcoin out of the vault and it's in the waiting room, if we put it back into the vault, I still own those private keys. So you and I are just going to fight over this for eternity until one of us gets tired of paying transaction fees or something, or falls off the face of the earth. So it tends to be better to sweep it to set that other place it can go, this cold storage, as I've called it, to be different than the private keys associated with the vault. Right, so
Makes
that's
sense.
why we want to have a different cold wallet.
Totally.
The place that I think you're not quite right on is this final destination that we call Tyler here. That we don't need a list of any of that stuff when we set up the vault. And this is what's really cool about it. So your Bitcoin is in a vault and you want to take it out. You can specify wherever you want that to go. It does not have to be a predefined set of addresses, right? It does not have to be, this can only go to Tyler and Udi. This can go wherever you want it to go, so long as you have the private keys to the vault. And so you may say, hey, I want to send it to Elizabeth. Great. What happens is the exact same thing we see here. It goes from the vault to the waiting room, except now instead of specifying you want it to go from Jan to Tyler, it would say, okay, I want this to go to Elizabeth. Great. And so now we sit in the waiting room and we wait for, let's say, 30 days. And if you, Jan, decide not to cancel the transaction because you were the one who actually did it, eventually it ends up here over with Elizabeth. And if you're like, hey, what the hell? I didn't authorize this transaction. I guess Elizabeth has stolen my private keys. Well, you still have the ability for 30 days to say, well,
to cancel.
That's not good. Send this to cold storage. And as long as I have the private keys to the vault, I can spin from the waiting room to cold storage. And so Elizabeth isn't going to want to do that. She doesn't own your cold storage account, right? But the point is you have 30 days to look at this and say, hey, is the place this is going the place that I specified? Did I authorize this or not? And if not, you have the chance to say, send it elsewhere.
Yeah, that's pretty cool. Like, another question that I have for you, and obviously you mentioned the example of that you need to wait for 30 days. I mean, this is also something that you can specify, right? It doesn't have to be 30 days. It can be 1 hour, it can be 30 minutes, it can be one block. I suppose this is what you can do, right? But my question then would be, let's say you really set it for 30 days. Let's say this is kind of the setup of the vault. However, you then kind of want to speed up that process because you're like, okay, yeah, like no problem. Everything is good. I just want the transaction to be processed faster than me waiting for 30 days. Can you do that, or you're just stuck with it because you set up the vault this way and you cannot really mess with the settings afterwards the waiting room has been triggered?
Yeah, exactly. So when you set up the vault, the kind of third thing you specify is the waiting time.
Okay.
And it's, it makes sense, right? If
does
somehow
make sense, yeah.
with your private keys you could change the waiting time, then if I'm Elizabeth and I stole your private keys, I'd spin it to the waiting room. I'd say, change the waiting time to 1 block. Why would we wait 30 days? Let's go ahead and move it on to my wallet now. And so you don't really have a choice there. But what you could do is you could say, hey, I have various assets that I want to have a certain amount of time before they go away, right? So maybe I take my Graily Grail Quantum Cats and I'm never going to sell those. So I put those in a 3-month vault, right? With a 3-month waiting period. Because I say, I'm never selling these things. So if they're leaving my wallet, I want a long time. Maybe I'm on vacation for a month. I want to be able to get back from vacation, have a notification on my phone or email or wallet or wherever, and see that, oh, someone is trying to steal my Quantum Cats. I'm canceling this transaction. But maybe you have, some Bitcoin you use regularly for trading and you kind of mess around with it. Maybe you say, hey, this is a common thing. I don't want this in a vault. I spend it all the time. I'm fine with it getting drained. And then maybe you have some other Bitcoin where you're like, hey, I send this back and forth to friends. If there's something I want to make a bigger purchase that pops up on, I want access to this. I'm going to give it a 24-hour wait time. Just because, I'm mostly online. and I'm pretty sure I'll see it if someone tries to steal this Bitcoin. But if it all got stolen, it would suck, but it's not the end of the world. And so you have this sliding scale, and really what I would expect to see when Opcat goes live is people making vaults with different waiting times based on how often they're planning on using something and how important it is to secure that thing that they have.
No, totally. I think this is a really cool example, and I asked that just to kind of make that case very clear, because I think this is actually, very dope feature, right? Another maybe last question to this, because again, I think that this is something what many people that are maybe thinking even about using this for potentially trading and stuff. Obviously, you would probably not use a vault for trading, right? I think that is probably not the user experience that you're looking for, even if you set it for one block. You probably don't want to do that. You would probably just use hot wallet that, hopefully you only put the funds that, you're working with at that moment so that nothing really bad can happen. But, what do you think like use cases of this for like trading and specifically like even connecting to applications? Like, do you think that we could set up vaults, maybe just a couple blocks for things like, hey, I am connecting to this application with my Xverse wallet, and I don't know if I can trust it because I have never used it before, and it's a new kind of application, right? And they want me to mint something. And so maybe I can set up a vault just to kind of see, like, if the transaction that I do with this kind of, even like, yes, you should use a burner, but maybe you cannot use a burner because it's related to some assets that you have. Do you think that this is going to be a use case that you're going to be using vaults for as well? Or do you think it's just an overkill that is not really kind of, I guess, user-friendly for this scenario?
Yeah. I think it's an open question. So obviously don't click on links that you're not sure about, but vaults
100%.
are a big thing that can help with that. So maybe if you want to go click on links, you say, I'm going to put a 2-block.
Yeah.
I'm going to put my exploration wallet on a 2-block vault. And what that means is, yeah, okay, I'm not going to be able to spend out of it immediately. So if I'm trying to do stuff super fast, then that's not going to work. But if I wanted to click around websites and like see what was going on, like, and I'm going to connect my wallet, yeah, I absolutely would prefer it to be in this super safe feature. And as you said, maybe the drainer link only drains your wallet if you have more than $100 in it, and you don't find out that it's a drainer link because you viewed it with your Xverse wallet with $5 in it. And so, there's some niceness to this additional degree of security. I think by and large, though, the takeaway should be the only thing that shouldn't be in a vault is stuff you are actively looking to trade. And otherwise, you should just be willing to say, hey, everything else is going in a vault with some type of time delay. And great. And when I wake up in the morning or every Sunday, I take stock of what I did this week. I put anything that's not that, X amount that I'm willing to trade goes into a vault, and everything else, fine, it stays in the hot wallet. And we make that trade-off. We take the quick reaction for the chance that we don't get reactive security, which is what vaults provide.
So, okay, is that it, or do we need to look into another example here? I think the general idea is pretty clear here, right? Like, we have some very basic stuff on Bitcoin today, which includes the time locks and hash locks. And obviously with Opcat, we're going to be able to do a lot more stuff that, vaults are one example. But, another thing that we should talk about probably in the next episode, as we're going to talk about CatVM a little bit more, is bridges, right? Because I believe the same restrictions of where the money can go and if it should go somewhere really applies to bridging, right? Especially when we talk about permissionless and trustless type of bridges.
Yeah, so I think if you understood the vault example, you're actually halfway to understanding how these CatVM bridges work, which is really cool. So if we move from calling this thing a vault to calling it a bridge, you can kind of squint and start to see it. Oh, okay, so I put my money in a bridge, and then it can be spent out to, and then when it leaves, I can specify where it's going to go, right? So Jan, you're taking your money no longer out of a vault, but out of a bridge. Okay, great. Well, it can only go to this waiting room. And then the other question we have to answer is what happens in this waiting room to make sure, Jan, you can ultimately, take the money out. And that's where this optimistic withdrawal path, this permissionlessness comes from. And we'll get into that in another episode. But this vault construction is actually at the core of the CatVM bridge, which I think is really cool.
Yeah, let's discuss it in the next episode so that, this one is not that long. I think it's also, people have to think about this a little bit more. Maybe think of these examples and kind of try to imagine like how it actually works and why it works this way. I think, we have provided a pretty good overview. Obviously, if anybody has any questions in regards to any of these topics that we covered in today's episode, feel free to reach out to us. Tyler, this was great overview. I'm pretty happy with it. I don't know if you want to summarize it or if you want to add anything else to it, but I think this is pretty cool.
Yeah, I guess if we do our quick summary at the end here, we started out the episode talking about how, one, don't let your friends tell you Bitcoin doesn't have smart contracts. Just because we're not the sharpest tool in the shed doesn't mean we don't have something available to us. And so, again, Bitcoin was basically the inventor of smart contracts. Covenants are what we say the way to restrict future flow of Bitcoin. And so we talked about time locks and hash locks, which are two covenants that exist in Bitcoin today. And then we talked about how Opcat enables more expressive covenants. And really, when we say more expressive covenants, when we talk about what Bitcoin script allows you to restrict, today it allows you to restrict who is allowed to spend the Bitcoin and when they're allowed to spend the Bitcoin, but it doesn't let you specify where they're allowed to spend the Bitcoin. And what Opcat lets us do is it lets us take care of that where feature that's currently missing in the Bitcoin language. And so we talked through an example of a vault. I definitely encourage you all to think more about that. There's some really awesome content out on Twitter from the Taproot Wizards community explaining vaults, so definitely go check that out if you want to dive deeper. And we hinted a little bit about how CatVM's permissionless optimistic withdrawal mechanism, this bridge, actually relies on Opcat-enabled covenants that look a lot like the vault we talked about today. So I'm excited to talk more about CatVM in the future, but I think this was a big chunk to bite off today, so we'll wrap it here.
Amazing. Thank you, Tyler, and see you guys soon.
Thanks, Jan. Bye, everyone. Hey, everyone. Thanks for being Technically Bitcoin viewers. It's been amazing to go on this journey with you all. I know Jan and I have learned a ton throughout the process. We love meeting you all in person. The support has been overwhelming. Today, we're opening up donations, and it's not for me or Jan. It's for our amazing producer, Jason. He puts in a ton of work behind the scenes, and I think it doesn't go unnoticed by us, but I think we would love support from the community for him. There are tools we would like to have. There are services we would like to use. We'd like to pay for Jason's ticket to the next big Bitcoin conference. And with your support, I think we'll be able to do that. So if you enjoy the videos, if you have some sats laying around and you're willing to contribute to this, we'd really appreciate it.
Let's go. Anything goes, guys. Really appreciate it again. And we're going to see you soon.